Welcome. Today we're going to learn about the disk method with a vertical axis of revolution. So let's start with an example. If you're asked to find the volume of the object created by revolving the area bounded by the graphs of the following equations, y equals x, y equals 0, y equals 3, and x equals 4, about the line x equals 4, you're going to need to use either the disk or the shell method to calculate this. So we're going to use the disk method today. So you want to start by graphing. So that's step one. So what we're going to do is we're going to take each one of these equations and we're going to graph them. And if you look at the graph that we have created here, you'll see that our graphs basically bound a particular region. And I've shown this in orange with an orange symbol. So you can look at that orange shape, and that represents the region that's bounded by all these equations that we have. If you look about, the next step is to look about the line that we are going to revolve this region around. And that, in this case, is x equals 4. So if you notice the line x equals 4, you'll see that I have kind of these arrows around it because that's what we're revolving around. So if you want to imagine taking this orange region and revolving it around that line, that vertical line, we call that a vertical axis of revolution, but that's because it's vertical. And we're going to revolve around that. We're going to create a volume. And your job is to calculate what that volume is. So after we've graphed everything, then the next step, step 2, is to place a rectangle inside the bounded area. And because we're using the disk method, we want to make sure that rectangle is perpendicular to our axis of revolution. So the axis of revolution, as we stated, was x equals 4, that line, which I've shown in blue. And we place this purple rectangle that I've shown perpendicular to that line and within that bounded region. Make sure all the ends of that rectangle touch the ends of that bounded region. So we have to establish that. And this rectangle is key because it's going to be representative of the volume that's going to revolve around that vertical axis. And if you take that and you revolve it around, you're going to create a disk. And that's why we call this a disk method. Okay, so step 3. We want to identify the short end of our rectangle. That determines whether our integral is in terms of dy or dx. In this particular case, if you look at A, you'll see that I've identified that short end of the rectangle. And since it's vertical, it's going to be in terms of dy. That's key because that means everything in our integral is in terms of y, not x. So step 4, based on the information below, we begin to build our integral. This is the formula and the integral that you need when you use the disk method to calculate the volume. And if you look at it, you can kind of see that pi r squared, which would represent the area of a disk. That's the concept here. But obviously it's a volume, and there are going to be many disks that are going to be put together to form the total volume that we create with this particular region and this shape. So, part A, we want to use the disk method when our rectangle is A, perpendicular to our axis of revolution. We already discussed that. B, we want to use this particular formula when the small end of the rectangle is vertical because everything's in terms of y. And C, the rectangle touches the axis of revolution. If it doesn't actually touch that axis, if there's a gap there, then you're going to have to use the washer method. And your formula is going to look a little bit different than this. So for the moment, we're going to have a situation where it does touch it. So we're going to use the equation that we have in this particular example here. Okay. Now, step 5. We want to now fill out this integral. So we need to find all the parts to it. one part is r of y. So we have to know what r of y represents. Well, in our example, r of y is measured from the left side of the rectangle to the axis of revolution. And if you look in our particular diagram, you can see I've identified what r of y is. And if you look at that measurement, it's actually a horizontal measurement. Now, anytime you want to calculate a horizontal measurement, you take the right side of it and you subtract the left side. So if you look at the right side of the rectangle, remember this isn't, it's a horizontal measurement, so it's the x measurements that we are trying to calculate. So x is 4 on the right side, okay? And then x is on the left side. That particular equation, y equals x, is what touches the left, where the rectangle touches on the left side. It's the equation y equals x. So x is 4 on the right side and y on the left side. So as I told you, you take the right side minus the left. So it's 4 minus y. That's how we calculate r of y. Now, step 6, we have to identify the limits of our integral. And in this particular case, if you look at our region, remember everything's in terms of y, we're looking at the y limits. So our region's y limits, or the boundary of our region, goes from 0 to 3. So those will represent the limits of our integral. Now we have everything we need. We're going to put it all together and in our formula that you see in item 1. So that's the formula. We go to item 2 and we plug in our limits, our 0 and 3, and we also plug in what we had originally calculated r of y to be, which is 4 minus y. We put that right in. And then in step 3, we start to do our calculation. So first step is to square 4 minus y, which we've done. And then in step 4, we actually do the integration of each individual term. And then in step 5, we plug in our limits from 0 to 3. So first you plug in 3, and then you subtract 0. So everything turns out to be 0, so that's nice. And then in the last step, we're going to simplify, and in the end, we get our answer as 21 pi. And that is how we do the disk method with the vertical axis of revolution. Now go practice, practice, and practice some more.